Thank you. This is my first time at PyCon and I've really enjoyed it. I'm really enjoying it. Yeah, I'd like to do a little talk today about visualizing environmental data with Python and a particular library I'm using a lot at the moment called Bokeh. I'll talk a little bit about the background to the work and then why I chose Python, because I've done work in a few different languages over the years and I found Python particularly suitable for this, so I'll talk about why. I'll go into the software development bit and then some examples of it to working, hopefully. Sorry, can you not hear too well? Is this too... How far?
That doesn't do the room, that only does the recording.
Oh, I see, right. I'll speak up, sorry. I'm speaking more slowly. So, I'll go through the... talk a little bit about the development itself and then show some examples of the software in use and talk about the benefits I think it gives, and then I'll take some questions at the end. SEA is a company of, I think, about 300 odd people at the moment. We do a range of stuff ranging from building acoustic arrays for sonars all the way through to developing software for the transport industry. I have a bit of a niche role within it. I'm a data scientist and my speciality is underwater environment, really. So that's primarily oceanography, underwater acoustics and sonar, and within that I do quite a lot of numerical modeling, and there's a very large part of it is all pretty much all software design, development and testing. And the motivation for this particular piece of work is the very large quantity of environmental data that is now available over the internet. As technology has improved, numerical models of the environment, weather forecast models, ocean forecast models have become faster and faster, more and more capable, churning out more and more data. And of course these days with fast broadband access as well, it means you can get access to that data quite easily and do a lot of interesting analysis and visualization with it. So why Python? Oh, first of all, so the main enabler for all of this is data, really. There was, quite a few years ago in my particular field, you tended to have to go to specialist providers to get the sort of data that I'm talking about, oceanographic data. But now so much of it is available over the internet, and there are many internet-connected sensors, models, databases, you name it. There's just tons of data out there. It's all available, everything from satellite remote sensing through to autonomous ocean gliders, forecast models, and Argo floats. The picture on the left, I don't know how well you can see it there, but it's taken from Wikipedia Commons, and it shows how data storage has increased. This is 1986, 1993, 2000, 2007, so it's 10 years old, but you can see the trend very clearly. Most of it's digital now, and of course it's expanding exponentially. 280 exabytes back then, that's an exabyte's 10 to the 18 bytes, so that's a million terabytes, I think. Is that right? So a lot. As an example of where you can get your data from for oceanography, the right-hand picture shows the position on the 24th of October of 3 days ago of all the Argo floats, which are instruments which just drift in the ocean, I think about 1.5 kilometers depth. They just drift along, and every now and again they pop up to the surface and collect the temperature and salinity data. They've got temperature and salinity sensors as they go, pop up to the surface, radio it back, and sink again. And they keep doing this. There's about, as it says there, 3,778 operational at the moment, and the reason is to enable studies of climate change. Temperature and salinity are the two main parameters you need to know about the ocean to study climate change, and all of that data is freely available. To step back a bit and talk about why I ended up with Python. Going clockwise around this picture is my programming journey, stretching back quite a long way to 1983, in fact, where I started programming the Oric 1, which was a bit like the ZX Spectrum, similar sort of hardware, but whereas the ZX Spectrum had hundreds of games, the Oric 1 had 6, I think it might have got up to 7 possibly. Then onto the Acorn Electron, a cut-down version of the BBC, and there's an edible prize for anyone who can identify the computer in the top right there. So there goes the challenge. No. Good try. It does look quite similar. Anyone else? No. I'll tell you what, I'll leave it open during the talk, so you can always come back to it. But, And then through university was, where I studied physics, was mostly working on sun stations, doing programming in Fortran. And then through a load of other stuff, including VAX stations using VMS. I don't know if anyone remembers that at all. And then more recently, distributed applications. And basically, it's kind of a long story, hopefully reasonably short. I've done an awful lot of languages over the years, and I found that all of them are very good for certain things. C++, if you want, fast native code, and the ability to build complex systems with object orientation, it's ideal for that. But as soon as you start to do any GUI stuff or web stuff, it becomes a lot harder. Not impossible, just a lot harder. MATLAB, again, great numerical environment, but difficult to distribute stuff. I mean, sure, you can distribute source code, but it's expensive. If someone else wants to run your code, they have to buy MATLAB, and that's something like £1,500, I think, roughly, for a single user license. So they all have their pros and cons. And a few years ago, I was talking to a fellow software developer who said, well, why didn't you try Python? And I was tempted to say, well, what I really need right now is not another language. But he said, give it a try and see what you think. So I have. And my conclusion is it can do everything. So I'm very happy, and I'm not going anywhere. Well, I'm sure you all know much of this anyway, but I've listed some of the common things that people do with it. So numerical analysis is sort of stuff that you can do easily in MATLAB. You can do pretty much just as easily in Python with libraries like NumPy and the whole SciPy stack. It's very good at internet protocols with those built-in libraries, data visualization, as I'll be talking about today, web apps, all the rest of it. Distribution as well, that's an important thing. Things like the Python package index and Conda make it just so much easier to distribute things in a controlled way in a standard packaging format, which is great. And speed as well. I mean, it's an interpreted language, of course, but it's got a great C and C++ interface. I recently had to interface to a great big C++ SDK, and I found it was really good for that. It was really quite straightforward to do. And Number, of course, is a recent thing from the guys at Anaconda, I think, the core developers of that. I've used that as well, and that's pretty remarkable. I've got quite close to native Fortran speeds with it. What I've used is, the work I've done is, it's a really simple application. I mean, it just accesses data using a particular protocol called OpenDAP. It uses Bokeh to visualize the data in a certain way in the web browser. So I'll talk about the benefits of Bokeh later, but I personally like it very much because it's got a very high quality advanced graphics, sort of the sort of stuff that I was used to doing before in MATLAB and Matplotlib in a browser. All Python, that's the beautiful thing. So I didn't have to learn yet another language, JavaScript. So it was all Python. And it's got a server, so also you can have distributed apps. So that's one of the great things, because you might want to do some heavy number crunching on a server, but have your browser, which is all you need, on a thin client like a laptop or something. So a little bit about OpenDAP. Sorry, it's not desperately relevant to Python, but it is relevant to the work. That's what it stands for at the top. It's basically it's a protocol for scientific data exchange based on HTTP and MIME, and large quantities of environmental data, like oceanographic data, is typically stored in formats such as NetCDF, HDF, hierarchical data format. There's quite a few of these. Those are two very popular ones. But the idea is an OpenDAP server runs on a physical server somewhere. It accesses all those files, and it makes the data available in a transparent manner to the end user. They don't need to worry about how it's stored. It just makes it available in a certain way. So you just have to write a client that, or use one of the existing ones that follows the specification. And there are lots of OpenDAP servers. The HiCom one is where we're going to get a bit of data from later on. But there are lots of others, and you can see some very big scientific organizations use OpenDAP quite routinely. So I ended up developing 3 packages. These are all available from pip, and as I say, they're really fairly simple, but the top one is a simple OpenDAP client, so that's what handles grabbing the data from the OpenDAP servers. And it handles these OpenDAP things, which are dataset descriptor structures and dataset attribute structures. These are basically metadata. And then it handles the actual data request itself. And then so slightly tortuous package names here. They're sort of amalgamations of the words, but so that's simple OpenDAP client. Bokeh color maps. This is using existing Bokeh components, but putting together basically writing a new class which puts together different plots to do something quite interactive. You'll see that in a moment. And then the actual app is called that, and it's basically, I'll show you in a moment, it's you can develop fairly rich GUI front ends using Bokeh. So what I'll do is sorry, I won't. I'll now go back into the presentation. I've got one slide. There's that from current slide. So an example of its use. So my main interest is in ocean data. I'm going to show an example now of getting hold of some data, ocean model data on the Gulf of Mexico. We can look at water temperature. And as I'm sure you're all aware from the news and everything else, the US Gulf Coast is very strongly affected by Atlantic hurricanes. I think the hurricane season is just about over now, but as you'll have heard, there's been a lot of them recently. They cause an enormous amount of damage. The Gulf of Mexico plays an important role because it strengthens hurricanes. It's warm, and obviously that's heat energy, which hurricanes pick up as they travel through the Gulf of Mexico and whip up the water. Hurricane Katrina is, I guess, the most damaging example. You can see the statistics there. It turns out that the Gulf of Mexico's loop current, which I'll show you in a moment, intensifies hurricanes considerably, and that's what made Katrina as devastating as it was. One of the things that did it. So there's a lot of work gone on in understanding the oceanography of the Gulf of Mexico, and there's an ocean model called HYCOM, which stands for Hybrid Coordinate Ocean Model. It's put together and run by a big consortium, and they run high-resolution models in that area so they can forecast conditions and try and help predict these things. So now I will break out the presentation, and right. So this is the application to save time. I've got it up and running already, but you can see basically I started the Bokeh server there at the command line. Don't worry about all those warnings. So you just you write your application, then you type Bokeh serve --show app, and then it starts the app up. And you can see I've got a reasonably rich GUI here. I'll zoom in a bit just so it becomes the wrong way. Right, so I've got two tabs here. Oh, the first thing I do is I've just taken the address of the OpenDAP server for the Gulf of Mexico daily forecasts, which is there on the HYCOM website. I've dumped it into my application here, click the button to open the URL, and then it shows you the dataset descriptors structure. And this is all in a Bokeh data table, which I think is based on SlickGrid. But it's very good. You can do things with it, reverse it, sortable, all those sorts of things. I've just displayed the data here. But this is the metadata, basically. So it tells you the variable, the data type, dimensions. These are it's high-dimensional data because you typically have time of forecast, latitude, longitude, and depth. You're dealing with volumetric data over time. So then with another couple more button clicks, you can select a particular variable. We've selected temperature here, and then that will give you the details of that variable. That's the data attribute structure I mentioned earlier. And it dumps the dimensions of the data into this table. Then you can select which ones you want. I've selected the most recent time. MT is forecast time, and I've gone for all the depths, as you can see. I've gone for all the lats and longs, but I've slightly degraded the resolution just to make the plot respond a little more quickly. That's nothing to do with Bokeh and everything to do with my laptop, which is not the most recent laptop. So if you go on the data visualization, this shows, I'll zoom out again so you can actually see. Right, so the color map's an existing Bokeh widget, as is the color bar below there. And Bokeh, of course, can do line plots as well. What it is stuck all these together in a class, which basically enables you to see something of the three-dimensional data. So what you've got here, the color map, often called a heat map, and this is temperature, so I guess that's actually literal. But you can see the temperature distribution at the surface, depth 0, and as you go down in depth, move the slider, you can see how it changes. This is the sort of thing that previously I had to do with a series of stack plots in matplotlib or something like that. It's perfectly possible, but it's a bit slow and clunky. The other bit I added to this was to have this scanning cursor, which shows you the depth profile and latitude and longitude. So you can see as I move around, you can see this is the loop current I mentioned earlier going around here. And you can see that these temperature structures remain, if you look at the plot on the right, that's temperature on the x-axis and depth on the y-axis, and you can see that these structures remain hot, quite deep. Thanks. So that helps you to explore that. That sort of approach helps you to just scan around and see if there's anything interesting happening depth-wise. Then, of course, you can scan down to particular depths. And if you look down, you'll see that. Again, this would be faster on your laptop, I'm sure. But you can see that these structures, these eddies, span out of the loop current actually stay warm quite deep. And that was one of the issues with Katrina, I understand, is that because the temperature remained high quite deep, the hurricane goes through, whips up water, gains energy from heat underneath the surface. It's not just the surface that matters, that's the issue. So, and the track of, I think if you, the land mask has changed with depth as well. New Orleans is about there, I think. And this is the track it took, up there. Now, this is a forecast from a couple of days ago, but I don't think it looked that dissimilar presumably on that day. So it picked up the heat as it went through. So that's the sort of interactive thing that I did. But okay, there's various other things you can do with a server. This is all running within the web browser, as you can see. Because it's run from a Python server, of course, you can do lots of back-end processing and change things. For example, if I do things like click these boxes here and update the display, it will flip the data and plot it upside down. Not very useful in this case, but sometimes things come out in a different plot than you would like. So it's possible to do that sort of thing. So I'll just nip back to the slides now. Right, where were we? Okay, slide. Right. So that was in case oh yes, that's actually from a different day. You can really see it. This was in case the demonstration didn't work. This was from a different day. You can really see a warm core eddy there quite clearly, can't you? That sort of red spot there. Briefly, I'll just cover the development experience itself. In terms of developing the data access client for OpenDAP, there was a specification to follow, and I found the Python standard URL lib library did everything I need. So it was just a question of reading strings and decoding it according to spec. So that was really quite easy to do. It also included proxy handling, which is useful because most corporations, I'm sure you know, run proxy servers, so you have to be able to get through that to get to the internet. Bokeh is under development. I think it's getting quite close to 1.0. There's a very active user base and forum. It was changing rapidly when I was using it, but I still found that with some help from the forum, it was possible to get things done quite quickly. And it's well designed, I would say, for both simple and advanced use. You could just simple line plots are very, very quick to do, but you can build some reasonably complicated custom classes, the sort of thing I was doing there without too much difficulty. And I lied about no JavaScript, sorry. I needed some, but it's only 25 lines or so out of hundreds. So the benefits, well, I've already said Python, one language. It can do everything I need to do, certainly. And Bokeh, I think you've got powerful interactive visualization, and you can imagine how you could, as I say, have a powerful server somewhere and a very thin client. That distributed nature of being able to visualize data in that way is very powerful, I think. Yeah, acknowledgements. Thanks very much to the PyCon organisers and sponsors, to HiCom and OpenDAP Consortium and organisation, and the Bokeh community. And finally to all of you for listening. Thank you. And there's some links there at the bottom if they're of interest. You can find out more about OpenDAP and Bokeh, and the packages I was talking about earlier are available on pip, and the source code's available on Bitbucket. That's it. If anyone's got any questions.
Thank you, Marcos. Yeah, plenty of time for questions. Yeah, the back.
And that should be your talk. If only to what extent did you consider Jupyter notebooks and widgets within notebooks? And if so, what was your rationale for choosing Bokeh versus widgets, Jupyter widgets?
It's a good question. I've used widgets within notebooks as well. It was really the server aspect of Bokeh, I think, that drove me down that library, because you can, the back-end server, you can do pretty much anything you want to do. You know, you can have some fairly complicated signal processing or data processing or whatever, and have that react to events in the browser. That was the key thing about Bokeh for me, really. What else? Questions?
You mentioned acoustics earlier on.
Yes.
What are you trying to listen to?
Oh, right. It's well, the sonars are strongly affected by the underwater environment. The same variables we were talking about earlier, like temperature and salinity. So, and there's a whole load of researchers out there modelling how sound travels underwater, and it changes with the depth of the ocean, the season, because that affects the temperature and salinity profiles, and the slope of the seabed, and a whole host of other stuff. So, I'm happy to talk about that afterwards, but I couldn't go into too much more detail now, I'm afraid. Anyone else?
What was the missing computer?
Sorry?
What was the missing computer?
The missing computer. Oh, right. Yes. Well, no one's got it, so well tried. It was a Tatung Einstein, which is a great computer, but it didn't sell very well. It was relatively expensive and very good. But, so no one won the Mars bar, I'm afraid, sorry. But you can all share it or something. Anyone else?
Any more questions? I have one. Anyone from the audience? No? I'll go. So, Bokeh, Matplotlib, Seaborn, Plotly, Hash. Do we need more? How do we choose?
How do we choose? That's a good question. I mean, there are so many, and they are all so capable. I had a particular requirement here I was very interested in visualizing in a browser so I could be truly cross-platform and get away from different GUI frameworks and stuff, and also have some powerful backend server stuff going on, like bits of modeling and complex data analysis. So for me, Bokeh, I think, was a reasonably clear choice. I'm not saying it's the only thing that can do that, but it was a good choice. If you want something that just runs in the browser, I think Plotly does that, doesn't it? And very well, I'm sure. I don't know it, but I'm sure it does. So yeah, there's a lot of choice. It is hard to choose. That's both a blessing and a curse, I think, isn't it? Because you can spend a lot of time working out what to use before you start using it.
Thank you. Any more questions?
Why is the temperature so uniform near the top of the sea?
That's the mixed layer. Is called. Sorry. Why is the temperature so uniform near the top of the sea? That's called the mixed layer. It's basically because you have wind and wave action at the surface and mixes it up, and it makes the ocean isothermal and isohaline near the surface. That's got very interesting consequences for acoustics. The man who asked about it over there. But that's why, basically. You find that the mixed layer is very deep in the winter. You get surface heating in the summer and much less mixing, so you find it's a lot shallower and sometimes non-existent in the summer.
Will you be around for the rest of the weekend?
I'm around tomorrow. I'm not here on Sunday, though, I'm afraid.
Okay. Well, if you want to talk about data visualization.
Yeah, please do. Come and give me a shout.
Thank you, Marcus, again.